MS Ramaya University of Applied Sciences.
Hello friends, with this experiment we are determining the compressive strength of the given sample of cement. Apparatus: standard cubical mold of size 70.6 mm x 70.6 mm, poking rod, vibrating machine. Materials: cement, sand conforming to IS 650 1966. Strength test is not made on cement paste because of the difficulties of excessive shrinkage and subsequent cracking of neat cement paste. Hence, strength is found indirectly by conducting test on cement, sand, mortar cubes. The sand to be used for the mortar shall be a mixture in equal parts of 1, 2 and 3 grade of Ennore sand, that is standard sand. The ratio of cement to sand in the mortar shall be 1:3 by weight. The percentage of water to be added to prepare wet mortar has to be P by 4 plus 3 by weight of dry mortar, where P is the percentage of water by weight of cement required to produce a paste of standard consistency. Procedure: preparation of test specimens. Clean appliances shall be used for mixing, and the temperature of water and that of the test room at the time when the above operations are being performed shall be 27 plus or minus 2 degrees Celsius. Potable or distilled water shall be used in preparing the cubes. The material for each cube shall be mixed separately, and the quantity of cement, standard sand and water shall be as follows: cement 200 grams and standard sand 600 grams. Water percent of combined mass of cement and sand, where P is the percentage of water required to produce a paste of standard consistency, determined as described in IS 4031 Part 4 1988 or experiment number 1A. Place on a non-porous plate a mixture of cement and standard sand. Mix it dry with a trowel for 1 minute and then with water until the mixture is of uniform color. The quantity of water to be used shall be as specified in step 2. The time of mixing shall in any event be not less than 3 minutes, and should the time taken to obtain a uniform color exceed 4 minutes, the mixture shall be rejected and the operation repeated with a fresh quantity of cement, sand and water. Molding specimens. In assembling the molds ready for use, treat the interior faces of the mold with a thin coating of mold oil. Place the assembled mold on the top of the table of the vibration machine and hold it firmly in position by means of a suitable clamp. Attach a hopper of suitable size and shape securely at the top of the mold to facilitate filling, and this hopper shall not be removed until the completion of the vibration period. Immediately after mixing the mortar in accordance with step 1 and 2, place the mortar in the cube mold and prod with the rod. Place the mortar in the hopper of the cube mold and prod again as specified for the first layer, and then compact the mortar by vibration. The period of vibration shall be 2 minutes at the specified speed of 12,000 plus or minus 400 vibration per minute. At the end of vibration, remove the mold together with the base plate from the machine and finish the top surface of the cube in the mold by smoothing the surface with the blade of a trowel. Curing specimens. Keep the filled molds in moist closet or moist room for 24 plus or minus 1 hour after completion of vibration. At the end of that period, remove them from the molds and immediately submerge in clean fresh water and keep there until taken out just prior to breaking. The water in which the cubes are submerged shall be renewed every 7 days and shall be maintained at a temperature of 27 plus or minus 2 degrees Celsius. After they have been taken out and until they are broken, the cubes shall not be allowed to become dry. Test 3 cubes for compressive strength for each period of curing mentioned under the relevant specifications, that is 3 days, 7 days, 28 days. The cubes shall be tested on their sides without any packing between the cube and the steel platens of the testing machine. One of the platens that shall be carried on a base and shall be self-adjusting, and the load shall be steadily and uniformly applied starting from 0 at a rate of 35 N per mm square per minute. Data collection and tabulation is as shown in the figure.
Hi students, now we will be doing the experiment on the compressive strength of cement mortar cubes. So if you had been come across the different grades of cement, like if I take up OPC, you have 33 grade cement, 43 grade cement and 53 grade cement. What does that number indicates? The number indicates the compressive strength of cement mortar cubes at the end of 20 days of curing. Okay, so now what we are going to do is we are going to do the casting of a specimen and we are going to check the grade of cement which is used for that particular mix. So the apparatus required for this particular experiment is, one is the weigh balance of 1 gram accuracy, the cement, what I taken is a OPC of 53 grade cement, sand, zone 2 sand has to be used, the mold, the mortar mold which is having a dimension of 70.5 by 70.5 and the base plate of it, mixing tray. We also want the gauging trowel and the water for preparing the mortar mix. Now let's start the experiment. I am going to take 200 grams of cement, I have taken 200 grams of cement, and also I am going to take up 600 grams of sand. If I take up 600 grams of sand, it becomes a ratio of 1:3, 200:600. I am going to add it in 2 stages. I am just adding 300 grams. Once again I am going to add 300 grams. I am going to dry mix the cement and fine aggregate sample. You can do this hand mixing or you can just go on with mixing the mortar using the mortar mixer. So now I'm going to add the water to it. How much the water to be added? It will be P by 4 plus or minus 3%, where P is the normal consistency. If the aggregate is in a wet condition, we are going to deduct minus 3%. If the aggregate is over dried, okay, then we are going to add up 3%. In our case it's a normal fine aggregate, so we are just going to make sure that it will be added at P by 4 percentage. So I calculated earlier, it will be 84 ml. I taken 84 ml of water. I am going to add it to the dry mix and I am going to mix it well. This is a prepared mortar mix. So as I told you, we can just go with the manual mixing or we can go with the mixing using the Digi mortar mixer. But whatever the technique you use for mixing, we are going to use the mortar vibrator for preparing the mortar cubes. I'll just go with the explaining the parts of this mortar mixer. This is having a vibrating table and there is an arm to place your mold. You can just place your mold here on this particular arm. You can just take it, place the mold and you can just put it inside. Let us do it. So this is a mold. I am going to place the mold on this particular arm. I am going to tighten this. It's now locked. I am going to place it on the mortar mixer. I am going to tighten the screws. After tightening the plate, what we are going to do is, we are going to put the mortar into the hopper. Actually, I'll just put 50% of it and I'll on the machine. If I on the machine, it starts giving vibration. So what I'll do is I'll just scoop the top surface, keep it in air for 24 hours, then I'm going to keep it in curing for 28 number of days. After curing it for 28 days, what you are going to get is a hardened specimen like this. We are supposed to do the test for 3 samples, okay, to get an accurate result. What we are going to do, we are going to apply the compression load for this particular specimen. So this is a compression testing machine. After preparing the specimen, we will just go on with the operation of it. What we are going to do is, we are going to take up the sample type. Okay, I'll just take up sample type. I'll just put enter. It has either it's a cube, brick or cylinder. I'll go over here and I'll feed the length of it. That is, this is having 7.05 centimeter. centimeter. Width same, that is 7.05 centimeter. Depth also same, it is 7.05 centimeter. So I'm going to give OK. I'm going to take up the operating mode that I want a compression. I'll take up mode 1, enter. The unit will be in SI unit, and it shows the capacity of your mesh and it comes to the load thing. What we are going to do is, after that, we are going to place the sample to the compression testing machine. This is the sample what we prepared. I am going to place it on the compression testing machine, and I am going to run the experiment. So before running, make sure that your load release valve is locked completely and your emergency button is removed. Give a start command of your hydraulic jack and run the setup. It gives indication that the sample is broken. It is going to give you a peak load. So as I given the area earlier, what it is going to do, it is going to directly calculate the peak stress. So depending upon the compressive strength what you are going to obtain, you are going to get the grade of the cement. Generally it will be more than 53 Newton per millimeter square for 53 grade cement. This completes your experiment, that is the compressive strength of cement mortar cubes. If you just wanted to have a look at it, we'll just have a look at the specimen what we had been broken. So this is a broken specimen of prepared mortar cubes.
At MSR UAS, we spark your imagination unlike any other.